Okay, 7.2 is going to kind of similar to 7.1. We're going to build off basic concepts of fractions. So we're going to add fractions. We're going to use the idea of that adding fractions at even like adding 1/4 plus 3/4, very similar stuff. It's just we're going to be doing it with variables, rational functions now. So kind of in the nice case, and this was the nice case in basic fractions, is that if the two denominators are the same, we can just add the numerator. We don't have to do that much additional work. So x plus 3x gets me 4x, and then I don't change my denominator, it's 8. And then one of the things we always did with basic fractions is that if you can reduce the fraction, you should. So I can divide, or I can pull out a 4 out of the top and the bottom. So 4x divided by 4 gets me x, 8 divided by 4 gets me 2, and so I'm left with x minus 2. Now it seems a little bit scarier in this case, but I do have matching denominators again. I have two terms, but they're the exact same factor for the first fraction and the second. So if that's the case, I just subtract the numerator and the denominator. And now we're going to take a page out of the playbook of our last section, and we're going to factor my numerator. So that's a difference of squares. I'm left with x plus 3 times x minus 3 over x plus 3. I can cancel out my x plus 3's, and now I have to avoid the trap of thinking cancel means that my question goes to a 0. No, x plus 3, those canceling leaves me with a 1 on the top and a 1 on the bottom, or just an x plus 3. X plus 3 divided by 1 is x minus 3. X minus 3 divided by 1 gets me x minus 3. So that would be my final answer. I didn't even box it. Now, things get a little bit trickier when we don't have the exact same denominator. And so instead, when that doesn't happen, even with simple fractions, like if I'm adding 1/3 plus 1/9, those denominators are not the same. And so generally when I had those problems, my first step was to find my least common denominator. And so if I have single terms in every single one of my denominators, to find my LCD, I take every number in my denominator and find the least common multiple. Least common multiple of every number. So in this case, the 3 doesn't fit into 5, so my least common multiple there is 15. And then I go into each of my variables. So I see I have an x squared and an x. I'm just going to pick the biggest power of those x's. So that's going to be x squared. And then I move on to the y's. I only have a single y, so my greatest power of y is just 1. So kind of ignore all the time thing. My least common multiple of my numbers is 15. X squared is my highest x power, and just a single y is y to my, just a single y, or y to the first. I think things get a little trickier when we don't have single terms. So in this case, I have 3 different fractions, each with denominators that I can actually factor. So I'm going to factor all 3 of those denominators before I'm trying to determine my LCD. So x minus 16, I can use difference of squares to get x plus 4 times x minus 4. A terrible thing to factor. The next one I have to do factor by grouping. So a little quickly on the bottom left side, 2 times 4 gets me negative 8. I want to add to get me negative 7. Those two values are negative 8 and 1. And so I get, I can break up my negative 7x and get negative 8x plus x, or 1x. Can pull out a 2x for my first 2 terms, pull out a 1 since there is no really GCF in my last 2 terms. So I'm left with 2x plus 1 times x minus 4. And then the last thing is kind of one of the simple factoring problems. I want 2 things that multiply to get me 16, add to get me 8. Those 2 things are 4 and 4. So I get x plus 4 times x plus 4. Now, I'm looking for matches when I find my LCD. So they could be matches across all 3 denominators. They could only be matches across 2 denominators. They do have to be in different denominators. So one of the matches that I noticed is x plus 4. So that was in my first denominator and my last denominator. And notice how, since I have x plus 4 shared in the bottom, I can't cancel those out. That's not really a match, that doesn't count. So it's only if they're in different denominators. So I cross those out and I put that in my LCD. And now I look for more matches. Oh, x minus 4 matches in my first denominator and my second denominator. So I put that in my LCD after canceling them. And now I don't have any matches left. And so when I don't have any matches left, I just take the remaining factors and throw them into my LCD. Now, if you wanted to, you could multiply these out. It's a headache. It's not the easiest problem to do. And in general, you're actually kind of making your life more difficult in the end. So when you have your LCD, in this case, with a lot of factors and a lot of binomials going around, you should just leave it like that. Because if you leave it like that, you're more likely to kind of see cancelizations later on when we actually add a fraction. And so this slide and the last slide are worth rewatching if you weren't able to track, because they build into the next two slides, which is adding fractions. And in order to add fractions, well, you need to identify the LCD. So here's the first adding fractions. I have a single term in each denominator. To find my LCD, I start with finding my least common multiple of the numbers just in my denominator. I don't care what's happening in my numerator yet. And so that's 5. I only have a 5, so that's it. I look at my x's. The biggest power for my x is cubed, and the biggest power for my y is squared. And so my LCD is 5x cubed y squared. Now, when we were adding fractions, very basic fractions, and we had 1/3 plus 1/9. In order to add those two fractions, we needed to multiply whatever denominator that wasn't equal to my LCD. So in that case, I would multiply my 1/3 times a 3 on the bottom and a 3 on the top to get my 9. Same thing here. I want to figure out what's missing from my denominator to get my LCD, or what can I multiply my denominator to get my LCD. So for my first fraction, what's missing is a 5. I'm missing 2 of my x's, and then my y is actually fine in that case. So I'm going to multiply the top and the bottom by 5x squared. Now for my second fraction, the only thing that is missing is a single y. So I multiply the bottom by y and the top by y. And now once I multiply things through, I get 15x squared, and then my bottom matches my LCD. And then 4y in my bottom matches my LCD. And since my LCDs match now, I can go ahead and just add the numerators. Leave the denominator alone. And now if this could be simplified further, I would simplify further. In this case, we can't. 5 doesn't fit into 4. I don't really have any extra terms lying around. I can't factor. And so that's my final answer. Now in this case, it seems like maybe what I should be doing is I should multiply my first fraction by 2 minus x and my second fraction by my x minus 2 to get some sort of LCD. But hopefully at this point, your brain's kind of, alarms going off in your brain thinking, ooh, these are very close to each other. The denominators are. In fact, the order just seems a little bit off. And when that happens, we've seen it in factoring by grouping. We saw it in simplifying fractions. Sometimes it makes our life easier to factor out a -1, or in this case, multiply a -1. Because if I multiply a -1, or my fraction by a -1, then what happens is my denominator changes to an x minus 2, and I get my LCD. They match up. I don't even really need to find the LCD. And I just have to make sure I multiply the top by -1. So 4 times -1 gets me -4. X times -1 gets me -x. And then it's a good idea, if you are subtracting fractions, to kind of put a parentheses around the entire numerator of the fraction that you are subtracting. The reason for that is you're more likely to kind of see the fact that that negative is going to distribute twice. So that's exactly what we're going to do. So -1 times -4 gets me +4. -1 times -x gets me +x. And now I just go ahead and combine like terms. 2x plus x is 3x. 3 plus 4 is 7. I can't simplify that any further, and so that's my final answer. And you might be thinking, oh, okay, every time we get a final answer, it's not going to simplify it and we'll call it a day. That's not always true. You got to check for that. Just because you see 7 problems in a row that didn't simplify doesn't mean the 8th one won't. So here we are going to find the LCD, but it's actually not too terrible to find. So the one that I went through when we were just talking about an LCD, we had to factor 3 different denominators. In this case, we actually only have to factor one of them, because x plus 1 doesn't factor any further, x minus 1 doesn't factor any further. So all I'm really going to do is factor x squared minus 1. And so, well, that's a difference of squares, so that becomes x minus 1 times x plus 1. And now my animations are a little bit off, so I'm kind of spoiling the result, but we think about matching again. And so I look at my fractions. Oh, I have an x minus 1 in my last denominator. I match it to my middle denominator, cross it out, put it in my LCD. I have an x plus 1 in my last denominator, an x plus 1 in my first one. I cancel them out, put it in my LCD. And then we could carefully write it out, but actually that cancels every denominator. So I don't have any leftover factors that I need to throw in my LCD. And in fact, that is my LCD, x minus 1 times x plus 1. And now I'm going to go fraction by fraction, multiply what's missing from my denominator to get my LCD. So the first fraction I need to multiply by x minus 1. I'm going to do that by to the top and the bottom. The second fraction I have to multiply by x plus 1. And then my last fraction is actually not missing anything, so I'm not going to multiply the numerator and denominator by anything. So once I kind of multiply those things out, I get 3x minus 3, and now my first denominator matches my LCD. I get 2x plus 2, and now my denominator matches my LCD. And then in my last fraction, I'm going to leave it in factored form. So you could put it back to x squared minus 1. There's a couple of issues with that. One, it's going to seem like you actually don't have all common denominators. And two, it's going to be harder to see when things cancel. So just leave it in factored form. And now I just have to be careful. I'm going to add all of my numerators, but I have a negative in front of my second fraction. So I'm going to subtract both of those terms, or I'm going to multiply both of those terms by -1. And now that I've gotten past that step, I can just go ahead and add all of my numerators together. 3x minus 2x gets me x. -3 minus 2 plus 6 gets me 1. And now I see I can actually simplify this fraction. I have an x plus 1 on the top, and x plus 1 on the bottom. Those cancel out, leaving me with, again, avoid the thought that it's 0. That just leaves me with 1 in the numerator, and then my leftover factor on the bottom is x minus 1 in the denominator.